This is a service provider class, and this class definition results in a build error. Let's talk about errors. And I've always said at this level, if they say it results in a build error, please don't look for missing semicolons or spelling errors. If you actually find a missing semicolon, just put it there and keep looking, okay? We don't deal with syntax errors. We deal with, well, it's a syntax error, but from a concept perspective, do you understand why? Like it's actually failing, not just type. Yeah, we don't deal with typos or typing errors, we just deal with actual errors. And again, you know, what I love about this question is not every question that tells you that this is about reflection. Sometimes they just throw the question and they say nothing. Like in this case, nothing in here says reflection. So if you're in the exam, they say this question is failing or this thing is failing, can you correct the error? You do not need to rewrite the whole class definition. You only need to indicate clearly where you make the correction. Now, to be honest, in this module, you see a class that has a key object macro. You only ever do this in two topics. The first one, reflection. The second one, threads. You would know this is not threads. You know why when you get there. So if you're looking at a class that has a key object macro in there, I mean, obviously, you know this is reflection because that is the only ever time you make a class and you give it the key object macro. Not only that, can you see that there's a property in here? Now that makes it really, really, really obvious that this question is about reflection. And every time you talk about reflection, two requirements. Number one, you must have the key object macro. Number two, your class must be a key object. So again, it's just one mark, which means it's something you should pick up very quickly. You see the class, it's reflection. You see reflection in a class header. This is a class definition. That's why I keep saying, learn to simplify your questions. If it's a class definition and you've figured out its reflection, nothing needs to be done except making it a key object, putting your macro and putting your properties, nothing else. So if I see you thinking here, I'm wondering, what are you thinking? Like, what are you trying to do with this class? Are you trying to invent your own way of writing classes that we didn't know about? You see, it becomes simple once you start thinking like that. 1.2.2 then says, what is the purpose of the macros present in the class definition? Briefly explain the practical programming benefits of a class that implements them. Now, these are just theory questions which you need to understand a little bit. What macros are we talking about? We are talking about these two guys, right? What is the purpose of these macros? And can you briefly explain the practical programming benefits of a class that implements them? In other words, what are the benefits of putting these things in? What are they allowing us to do? That's cool, right? And the answer is reflection. They allow us to do reflection. What are the purposes of these two macros? Why do you need this? So that your meta object compiler can generate your meta object. And your properties are required so that we can use reflection to set or retrieve values. So when it comes to answering these questions, sometimes there's no one straight single answer. You can play around with the words. And again, you guys have got memos for these questions. I'm just explaining them, but I've already uploaded the memos so you can go there and go through all the solutions. I'm just trying to make sure that you understand what we are doing. So that's reflection for you. So and I want you guys to go and look at different questions about reflection and start flexing your muscles there. Here's 1.3. Assuming that the build error in the class definition in 1.2 has been corrected, write down what will be returned by the following function in the code below is executed. Now, This is the code I was talking about. And two things will happen. Either they will ask you to write it, or they'll write it for you and you do other things. But otherwise, this, if you're in the exam, obviously for you guys, this won't be true. And you're looking at this thing for the first time, just skip the question. Because, and that's one thing I love about this module. That's one thing I love about these programming modules. You don't think in the exam. It's either you've seen it, you know what's happening, in which case you answer the question, or you've never seen it, therefore there's nothing to think, therefore you skip the question. So in most cases, you finish quite early, depending, obviously. So there's nothing to think in the exam. If you're going in the exam, what's meta object? Just skip, go next question. Stop wasting time, because there's no figuring stuff out in the exam, especially for these programming modules. Everything that you see in the exam, you must have seen it before. So this code, this is the code that probably is the most important code for reflection, where you get the meta object. I think we explained this code a lot during the assignments. You get your meta object. There's your for loop, which goes through all the properties, and you're supposed to do two things here: get the name of the property, get the value of the property. So this line gets the meta property, the Q meta property, which is the one that will give you the name of the property, right? So let me explain one thing here that maybe I haven't explained before. So when you have a Q object, right, your first step is to get the Q meta object, which is this line. This line will never change. It always looks like this. Constant Q meta object, you give your meta object a name equals whatever object dot meta object. Then you get the Q meta object. From this Q meta object, that is where you're going to get the name of the class. That is where you're going to get your meta properties, which will give you the names of the properties. So you've got this for loop here. One difference is this part. Sometimes this loop is written as for int I equals 0, I whatever, and so on and so on. And in this case, it's I equals meta. Well, that's a typing error, but again, don't worry about that. This should be, so let's just call this meta as well, right? So let's just call this one meta. So that means this here should be meta, like that, so that it matches, right? So that's what it should be like. Anyway, so these are those kind of typing errors you correct in the exam and you move on, right? So you get the meta object, meta, right? And what I'm talking about is this part, because others have asked, what's the difference between meta.set property offset and meta and I equals 0? Like, what's the difference? If you say for int I equals 0, right? It simply means you want to loop through all the properties. If you use for int I equals meta.property offset, it means you want to ignore all the properties that are inherited. You only want to focus on the properties within that class. What am I talking about? Let's go back to this question. Remember here, fiction inherits from book, which means in fiction, you're also inheriting the properties inside book. You understand? So in fiction, you've got two properties, your genre here and your title here. So if you then go for int I equals 0, this will loop through both properties, the one in the base class and the ones you inherited plus the ones in the current class. But if you go meta.property offset, you're simply saying, I want to ignore all the inherited properties. I only want to loop the ones within this class. That's what it does. Okay. And then here, meta.property count, I++, then you get the meta property. This never changes. It's always like this. Now, I want to explain from this line going downwards, right? You've got two options. One option is this. I'll come back to it. The second option is, okay, in this case, we want the name of the property, right? So we get the name of the property using prop.name. There's nothing wrong there, so I don't want to talk about that. So I actually want to explain starting from here, where we get the value of the property. There are two different ways of getting the value of your property. The first option is to use the name of the property, like we did before. The second option is to use the read function of Q meta property. So this line here, there's two options. That's one option. The second option would be something like this, which is what we did before. So remember here, let me type it here like this. This looks like oinfo.append, right? Prop.read b.toString, because it retains a Q variant, right? We talked about that before. Another option is you could simply go and use your property function. So you can go dot append prop, no, what is the object? sp dot property. You get the property, then you use the name of the property, prop.name, and then you then go dot to string like that. So this is what we did during our assignments. We just used we get the name of the property. Once we get the name of the property, we simply use the property function to get the property, to get the value of the property. And then you simply then go dot to string to make it a string. Or another shorter way is to use the read function of your meta property. So these are the two different options of getting the value of a property. And remember, the property function, whenever you read a property value, it is returned as a Q variant, right? It is returned as a Q variant. And likewise, your set property function receives a Q variant, which means it doesn't matter what you give it, it will convert it to a Q variant. And if you then want to retrieve the value of a property, it's returned as a Q variant, because we are saying it could be anything. It could be an integer, it could be a Q string, it could be a float, it doesn't matter. A Q variant is more like a generic type that can store anything, sort of, not really anything, but let's just treat it like that, right? It's more like a generic type. So once you get the Q variant, you can then cast it to its actual type. If you know that it's a string, then cast it to a string using the toString function. And again, this is all predefined functions. So those are the two options here when it comes to reading the value of your properties. Otherwise, you must not forget this code. We did this during the assignment. In this case, it should be SP, like that. That is the correct code for this part. It should be SP here. So this was a typing error. This was a typing error. It's like a copy-paste job gone wrong. So that should be SP. So the read function receives the Q object that you want to read from. In this case, this guy. Or you can simply use your Q object and then go dot property and then use the name of the property to read that property. And again, in both cases, you get the Q variant, which you then cast to a Q string. So this would give you a Q variant, just like this also gives you a Q variant. Which way you choose is optional. These are equivalent statements, but I'm explaining both ways so that if you are given the code, you understand how it works. Okay, so thank you for those questions, good ones. So now that we understand what is really happening here, the rest becomes logic. So again, look guys, you have to understand how your code works, right? It's not just about understanding reflection and only reflection, because there's always context. Everything else happening around your reflection, like in this case, there's the Q string list here. This is not just general programming, right? Like there's a Q string list here, this whole append thing going on here, then there's the join stuff going here. What's this stuff? Now that's just general stuff. It's not really like reflection or anything. It's just programming, right? And what's really going on here is, let's step through the code. They are saying that you have a function here, and your function is called function, right? And your function receives a variable of type service provider. That is the function. Okay, perfect. We'll come back to the function. Now here, we are declaring an instance of a service provider called SP. So we're going service provider SP equals new service provider. Then we give it these two arguments. What are these two things? There's no other way to know what these two things are but to go and look at the constructor of service provider, because new service provider, open bracket, this string, comma, this string simply means your constructor for service provider takes two Q strings. So let's go and look at service provider. How does it look like? Oh, and if you look here, here's your constructor of service provider. And indeed, it takes two Q strings, one called N, the other one called WS. We don't know what N is or WS is, but if we then look at the stuff under private, we can easily conclude that, oh, N is the name and WS is the website. So in other words, by looking at this information, you can figure out that, okay, we are making a new instance of a service provider and giving it a name and a website, right? That is what this line is doing. And the name is being given is provider A, and the website is being given is this guy here, www.providera.com, right? That is what we are giving this class. So now we know that in this particular instance, SP, the name is provider A, the website is this website. Now, after creating an instance of service provider, what do? We then call this function here, and we give it this SP, right? It takes a service provider. So we give it an instance of SP here. And they are saying, whatever this function returns, obviously that is what is going to be displayed. Now your job is to go and figure out what this function is doing with this instance so that you can figure out what it's returning or what it's displaying, or rather what it's returning. And now it brings us back where we started. Okay, so if we're a Q string list, okay, fine, we've got a Q string list. Cool, right? Yeah. What happens here? Now you see this, you know what's going on. Okay, we've got a meta object. We are going through all the properties. That's how I read code. Just like, okay, here's the meta object. Okay, now we are going through all the properties, and then what do we do with each property? Get that? We are going through all the properties, and this is what we are doing with each of those properties. It doesn't matter how many they are. We are doing this for each of those properties. Now, what are we doing? We are getting the meta property as usual, nothing new here. And then what do we do? Or info, the Q string list, dot append. We are inserting into this Q string list the name of the property. Okay. And we are also inserting into this Q string list the value of the property. So in other words, we keep inserting the name of the property and the value of the property, the name of the property and the value inside this Q string list. Okay, fine. So how many properties do we have so far inside SP? Let's go and look. We only have one property so far, which means this loop is going to loop only once for this property here. So what is it going to do? You know the name of the property. So it's going to get the name of the property, which we know, it's got name, and put that in this Q string list. So now we've got name inside our string list, right? And we go to the next line. It goes and reads the value of that property. What is the value of this property name? Well, inside our instance, we know that it has been set to provider A. So within this particular instance, we know that the name has been set to provider A. So this would return provider A. And we put that into this Q string list. Therefore, we put provider A inside our string list. And then we loop again to the next property, but there's only one so far, so this loop only loops once. And then we go to this line, which says orinfo.join. Join joins everything in your Q string list and puts a comma in between, which means this would then return name, comma, provider A. Provider A. This would be the output from this function. If we had two properties, it was going to be the name of that property and the value, comma, the name, comma, value, and so on and so on. So in this particular instance, this would return name, comma, provider A. So it sounds like a lot, but it's not. It's just that I'm explaining every little bit. But in the exam, if you're doing this, your mind has to move fast. Like, okay, I'm doing reflection, perfect, Okay, I make a new instance, I give it these two things. What are these things? You go back here. Oh, it's the name and the website. Okay, cool, name and website. So what is the name? Provider A website. Okay, that's that. Cool. We call this function in this instance. We go here, meta object, Okay, fine. We loop through our properties. How many do we have, by the way? Oh, there's only one property, so we only loop once. What we do, we get the name of the property, we put it in there, we get the value of the property. What is it, by the way? Provider A. Okay, we put it in there, and then we join. Okay, so it's going to be name and provider A. Done. That's how sort of fast you should go, because you know what's happening, right? Don't spend too much time on things like this. So the number of marks are actually, to some extent, an indication, or these 3 marks, an indication of how long it should also take you on that question. So that's reflection. So sometimes they ask you to write this code. Sometimes they give you the code and you just do the explaining. Now let's go to properties 1.4. Assuming that the build error in class definition 1.2 has been corrected, is the following code legal? If so, explain its effect. If not, explain why not. Okay, what's going on here? Set property. Every time you see a question about set property, they are just asking you about static properties versus dynamic properties. That's all. They will never ask you these sort of functions unless they want to test you on that. And what they are testing really is, we have created an instance of a service provider here, SP. Fine. But the issue is on this line, sp.setProperty. What is the name of the property? Website. What is the value? Here. Is this legal? In other words, the question is saying, we don't have a property here called website, right? Give me 1 sec, guys, just to attend to something here quick. I'll be with you now. Cool, sorry, I'm back. So I was saying, you see that, in other words, they are simply testing you on whether you are what's going to happen here. We are setting a property called website, which is not here. So is it going to fail or not? And then again, you come back to dynamic properties, which means it is legal and it will create a property called website as a dynamic property, and it will set its value to this. That's all you're doing here. And again, you've got the memo, so you can go ahead and look at that. So that's reflection for you. It just needs a lot of practice. But otherwise, there's only one other thing we haven't talked about here, which is an extension of this for loop. It's something we have never talked about. How do you get dynamic properties here using this code? Because as it is now, it will get only your static properties. But what if we have dynamic properties? There's another for loop that we need to add here for dynamic properties that we are going to look at towards the end. At this point, I want you to understand reflection with what we've covered so far. And then we'll talk about how do you modify or extend this code to also include code to get dynamic properties. And if you think about it, what we are saying is, in a few minutes, your meta object compiler is the one that is responsible for creating this guy. One critical thing I want you to know is that your meta object compiler runs at compile time before your program runs, which means it knows about all the properties you have defined in your class, because when it runs, it's before your program runs, right? Once your program is running, your meta object has already been created, which means you cannot get information about dynamic properties from your meta object because they were not there when the meta object was created. Your meta object is created at compile time before your program runs. Therefore, none of this will be useful for us to get dynamic properties, because remember, dynamic properties are created as your program is running. When it gets to this line, then it creates the dynamic property, which means it's not going to be inside your meta object. There's something else you have to do to get those values, but we'll talk about that one. It's only 2 lines of code. So that's reflection. In the meantime, I want you to practice on this.